Welcome back to my class in Assessment and Evaluation in Mathematics. For today, we will take up alternative assessment techniques or methods. But before we go into that, we first take the three fundamental educational principles which form the foundation of all assessment that supports effective education. The three fundamental educational principles are: number one, the content principle; number two, the learning principle; and number three, the equity principle. By the content principle, assessment should reflect the mathematics that is most important for students to learn. These mathematics that is most important for students to learn includes the basic mathematical concepts and the essential mathematical skills. And by the learning principle, assessment should enhance the mathematics that the mathematics learning and should support instructional practice. And by the equity principle, assessment should support every student's opportunity to learn important mathematics. There are 6 assessment standards, and these assessment standards were based from the standards of the National Council of Teachers of Mathematics. And mathematics teachers should take note of these standards and make sure that the assessment that they will give would accomplish these assessment standards. The content principle is reflected in the first assessment standard. The learning principle is reflected in the second assessment standard, and the equity principle is reflected in the third assessment standard. And the 6 assessment standards are: number one, assessment should reflect the mathematics that students need to know and be able to do. And the second assessment standard, assessment should enhance mathematics learning. Assessment should provide learning opportunities to students, as well as opportunities for students to demonstrate what they know and what they can do. Although assessment is done for a variety of reasons, the main goal of assessment is actually to improve students' learning and inform teachers as they make instructional decisions. That is, the results of assessments form the basis for making instructional decisions by the teachers. As such, assessment should be a routine part of ongoing classroom activity rather than an interruption. Third assessment standard says that assessment should promote equity. This implies that assessment should be a means of fostering growth toward high expectations rather than a filter used to deny students the opportunity to learn important mathematics. In an equitable assessment, each student has an opportunity to demonstrate her or his mathematical power or skills. This can only be accomplished by providing multiple approaches to assessment, adaptations for bilingual and special education students, and other adaptations for students with special needs. Assessment is equitable when students have access to the same accommodations and modifications that they receive in instruction. A fourth assessment standard says that assessment should be an open process. In this standard, there are actually three aspects of assessment that are involved. First, information about the assessment process should be available to those affected by it, which is referring to the students. Secondly, the second aspect, teachers should be active participants in all phases of the assessment process. And finally, the third aspect, the assessment process should be open to scrutiny and modification. The PIP assessment standard says that assessment should promote valid inference about mathematics learning. When do we say an inference is valid? A valid inference is based on evidence that is adequate and relevant. For example, a teacher may judge students' progress in understanding place value through informal interviews and use this information to plan future classroom activities. However, a large-scale assessment requires much more evidence and a more formal analysis of that evidence. The sixth and the last assessment standard says that assessment should be a coherent process. There are three types of coherence involved in assessment. Number one, the phases of assessment must be together. Number two, the assessment must match the purpose for which the assessment is being conducted. And number three, the assessment must be aligned with the curriculum and, of course, with instruction. Again, the three types of assessment that should be observed by mathematics teacher when constructing an assessment tool. And the first type is that the phases of assessment must fit together. Number two, the assessment must match the purpose for which the assessment is being conducted. And number three, the assessment must be aligned with the curriculum and with instruction, because it is only through this alignment that you can ascertain that the learning objectives prescribed in the curriculum is attained by the students, and the results of assessments would indicate if the learning objectives in the curriculum are actually attained or achieved by the students. These are some of the alternative assessment methods. Number one, individual and group tests. But this individual test in the form of paper and pencil test is one of the most common assessment method. But the group test is an alternative assessment method. Number two, authentic performance tasks. Three, portfolios. Four, journals. Five, interviews. Six, seminars. Seven, extended projects. And mathematics teachers should use a variety of assessment methods, because making use of a variety of assessment methods provides a more complete picture of students' learning. Some types of assessment tasks provide information about students' abilities to perform mathematical procedures. And other types of assessments involve higher level thinking and problem solving skills. And they represent meaningful instructional activities, and they usually invoke real world applications. And in using different or varied assessment methods, the teacher should be observant enough to see the changes in mathematics learning of the students. And Stenmark in 1991 described some of the changes in mathematics learning that should result from using these alternative assessment methods. These changes may occur on the part of the students, and there are also changes that may occur or should occur on the part of the mathematics teacher. According to Stenmark, effective use of alternative assessment methods should create changes in the way the students learn mathematics. And these are some of the changes that should occur among students in mathematics learning. Number one, students think more deeply about the mathematics problems. Number two, students feel free to do their best thinking because their ideas are valued. Number three, students ask deeper and more frequent questions of themselves, their classmates, and their teachers. Number 4, students improve their listening skills and they gain an appreciation for the role of listening in cooperative work. 5, students feel responsibility for their thoughts and ownership of their methods. Still on the changes in mathematics learning of students resulting from the use of varied assessment methods. Number 6, students observe that there are many right ways to solve a problem. Number 7, students experience the value of verbalization or articulation as a means of clarifying one's thinking. Number 8, students form new insights into mathematical concepts. That is, they form a new understanding, a better understanding of mathematical concepts. 9, students learn ways to identify the places they need help. That is the area or areas or aspects of mathematics that they are having difficulty and they think they need help. Number 9, students learn to identify the places they need help. These places are actually their weaknesses. 10, students increase their self-confidence and self-esteem as a result of the genuine interest shown by a teacher. There are some more of the changes in students in the way they learn mathematics as a result of the effective use of alternative assessment methods. Number 11, students feel more tolerance and respect for other people's ideas. And number 12, students learn to focus their energy on exploring and communicating ideas about mathematical relationships rather than simply finding answers. Number 13, students develop strategies for conducting self-interviews while solving problems in other settings. 14, students find satisfaction and confidence in their ability to solve problems. And lastly, students look less to the teacher for clues about the correctness of their methods, and students focus less on imitating the right way. Write the word right in open close quotation. So in number 15, students learn to be less dependent on the teacher. The teacher, these are some of the things that some of the good things that using varied assessment methods can do for the teachers. The mathematics teacher gain access to student thinking. Number 2, the mathematics teachers enhance their ability to use non-threatening questions that elicit explanation and reveal misconceptions. Number 3, mathematics teachers strengthen their listening skills. 4, mathematics teachers show respect for students by being non-judgmental. 5, mathematics teachers use interview results as a source of question to post on written assignments for the whole class, for instance. And number 6, mathematics teachers encourage respect for diversity by modeling appreciation of varied approaches. 7, mathematics teachers pose questions that encourage students to construct and share their own understandings. And lastly, mathematics teachers feel reinforcement for letting go of teaching as telling. First of the assessment methods is the use of individual and group tests. Traditionally, the dominant mode, most common mode of assessment has been paper and pencil testing of individual students. This testing often includes both selected response items and constructed response items. The most common selected response items that are used in paper and pencil testing are matching type, multiple choice, and true or false questions. On the other hand, the constructed response items for paper and pencil testing may include problems to solve, a short answer item, fill in the blank, or show your work questions. The words show your work are in open-close quotation. Again, the selected response items for paper and pencil testing may be in the form of matching type, multiple choice, or true or false questions, while the constructed response items may take the form of problems to solve, short answer test, question that requires short answer, fill in the blank, or show your work questions. Large scale testing often uses primarily selected response items because it would be difficult for the teacher to check a large group of students, the papers of large group of students. However, constructing good selected response test items is quite difficult. So many teachers rely more on constructed response items for classroom assessments. Some teachers check only answers while others ask students to show their work and provide partial credit to varying degrees. And more recently, individual tests have also begun to include open-ended questions like solve and explain your solution. These are some of the suggestions for mathematics teachers when constructing open-ended questions. Number one, the open-ended question should address the ability of students. The question should be constructed so that they cannot be answered by simple multiple choice responses or by yes or no or by true or false. The open-ended questions should address the ability of the student to form and communicate mathematical ideas and arguments. The open-ended question should also allow the student to see and make connections between the various content strands of mathematics. The open-ended questions should allow the students to make conjectures, justify results, organize and analyze data, and make estimates and predictions based on incomplete data or patterns of event. Number two, when constructing an open-ended question, the mathematics teacher should ask students to explain what students have been using when students have been using an arithmetic operation or algebraic procedure. Ask the students to explain in writing or with a diagram what that operation or procedure means and how that operation or procedure works. Furthermore, the mathematics teacher should ask students to explain how they got their answers. And this works quite well, not only for textbook word problems, but also for mental math and estimation problems. Another suggestion, number three, sample student papers randomly. You select a few papers or a few questions on each paper each day to review. Be selective about what is commented on. Choose one or two aspects for evaluation on scoring the detailed feedback. Fourth suggestion, teach peer assessment. Teach your students to assess each other's work. Review sample student answers with the class, asking students to suggest improvements. Share scoring rubrics with students. And the fifth suggestion is use the piles method for evaluation. Evaluation of open-ended questions can be done in several ways. For classroom tasks, the piles method is often appropriate and efficient. This is how you do the files method. You put each paper as it is read in one of three or more piles so that comparable papers are in the same pile. Labels or points can be assigned to the files after all of the papers are sorted. For assessments with more substantial consequences, it is important to ensure the reliability of the scoring. And sometimes two different graders will give the same paper the same score. Thus, scoring rubrics have been developed. Suggestion for constructing open-ended question is to actually develop a scoring rubric for the item that you are using. This initial analysis of your item will help you to consider exactly what a good response should include. However, it should be remembered that students may come up with an approach that you have not previously considered. So, be ready to adapt your rubric as necessary. Sample scoring rubrics will be discussed later. And the next suggestion is to use an analytic scoring rubric. This is for problem-solving tasks that rates students on three phases of problem solving. These three phases of problem solving are based on Polya's four-step method for problem solving. And in the analytic scoring rubric for problem solving, students are rated on these three phases of problem solving. These three phases are: number one, understanding the problem; number two, developing a solution plan; and three, finding the answer. It's an example of a scoring guide. It is a generic guide, which means that it is a general scoring guide. And for you to be able to adapt this general scoring guide to your own class or to your own needs or according to your own preference, you have to do some modification of this general scoring guide. This scoring guide is used for scoring open-ended questions. And the student who demonstrates proficiency gets the high score of 3 points. And proficiency has a student who demonstrates proficiency has the following attributes. The student provides a satisfactory response with explanation or explanations, and the explanations are reasonably clear and reasonably correct. And the explanations are accompanied by appropriate diagrams. And the student uses appropriate symbols or language to communicate effectively and exhibits his or her understanding of the problem. Further, the student uses appropriate processes and or description to answer the question. And the student presents sensible supporting arguments. There may be flaws in the answer, but any flaws in the answer is are very minor. Those are the attributes of a response from a student that demonstrates proficiency and gets the highest score of 3 points. For the student who demonstrates minimal proficiency, that student is awarded a score of 2 points. And minimal proficiency has the following attributes. The students provides a nearly satisfactory response which contains some flaws. For example, the student may the student begins to answer the question correctly but fails to answer all of the parts of the problem or omits appropriate explanations. The student may also draw diagrams with minor flaws, makes some errors in computation, misuses mathematical language, or uses inappropriate strategies to answer the question under consideration. And the student number 3, the student who demonstrates lack of proficiency is awarded a score of 1. Response that lacks proficiency has the following attributes. The student provides a less than satisfactory response that only begins to answer the question but fails to answer it completely. For example, the student provides little or no appropriate explanation. The student draws diagrams which are unclear, and the student exhibits little or no understanding of the question being asked, or the student makes major computational errors. All these attributes show that the student lacks proficiency, or the response of the student lacks proficiency. And the lowest level of achievement, which is awarded a score of 0, is one where the student demonstrates no proficiency. Attributes that show that the response demonstrates no proficiency are the following. The student provides an unsatisfactory response that answers the questions inappropriately. For example, the student uses algorithms which do not reflect any understanding of the question, or the student makes drawings which are inappropriate to the question. The student provides a copy of the question, an appropriate answer, and the student fails to provide any information which is appropriate to the question, or the student fails to attempt to answer the question at all. Those are the attributes of a response that demonstrates no proficiency and will be given a score of 0. Again, this scoring guide is just a guide and must be or should be or may be modified by the mathematics teacher to suit his needs or his preferences. Example of analytic scoring guide that is used for open-ended questions but for grading the student in three phases of problem solving. And the phase of problem solving is understanding the problem. And the student will be scored in this phase of problem solving as follows. If the student has demonstrates complete understanding of the problem, the student receives a score of 2. If the students demonstrates an understanding that shows misinterpretation or misunderstanding of part of the problem, the student will be awarded a score of 1 point. And if the student shows complete misunderstanding of the problem, a score of 0 will be given to that student. Phase of problem solving, this is how the students will be scored for the second phase of problem solving, which is planning the solution. And in this phase, if the student makes no attempt or totally has an inappropriate plan, that the student will receive a score of 0. But if the student has a partially correct plan based on part of the problem being interpreted correctly, the student will get a score of 1 point. And if the teacher sees that the plan could have led to a correct solution if implemented properly, then the student will receive a highest score of 2 points. In the last and third phase of problem solving, this is how a student will be scored. If the student shows no answer or wrong answer based on an inappropriate plan, the student gets a score of 0. And the student receives a score of 1 if the work shows one or more of the following errors: copying error, computational error, and the work shows partial answer for a problem with multiple answers. And the students will be given the perfect score of 2 points if the answer is correct and there is correct label for the answer, or correct unit for the answer if the answer requires that unit be written for the answer to be significant. Open-ended questions and scoring rubrics can be used for group as well as individual tests. Such tests are particularly appropriate for assessing problem solving, reasoning, communication, and use of tools and technology. Again, open-ended questions may be given for group or for individual student, and open-ended questions are particularly appropriate for assessing the following: number 1, problem solving; number 2, reasoning; 3, communication; and 4, use of tools and technology. These tests may include open-ended questions that may be answered with a single written response from the group, such as a paragraph, a letter, a graph, or a poster. Or the test may involve observing the group as it works for indication of appropriate understanding and use of the mathematical concepts and techniques. Some mathematics teachers like to combine both methods, observing students working together in a group and then having them write up independent responses based on their group work. Students may be assigned to groups randomly, for example, by drawing a card, or they may be tested in the same groups in which they have been working. Another alternative assessment method is known as authentic performance tasks. An authentic performance assessment starts with asking a student or group of students to engage in some mathematical task or investigation. Observations of the students as they work, questioning of the processes they use to solve the task, and examination of their final results are all standard activities that create useful data about what the students know and what the students are able to do. In using authentic performance tasks, the mathematics teacher should make sure the task is rich and motivating enough to produce sustained effort on the part of the students. Tasks which are boring or too simple for the students will not be very good performance assessment tasks. An example of a authentic performance task, it's entitled How Many Buttons? Miss Allen's fourth graders had just finished a unit on numeration that emphasized estimation. As a review, she had them estimate the number of buttons in their class on that day, collect and analyze data, and share their results with the class. As a performance task, she had them work in pairs the next day to estimate the number of buttons in the school on that day. Miss Allen has developed what she calls a proto-rubric, the beginning of a scoring rubric, which she will refine as she reviews the students' papers. So this method of qualifying or assigning a description to the responses of the students as good response, average response, poor response, and for each of these types of response, a score will be given to the students, and these are temporary and will be revised by the teacher as soon as she has read some of the responses or papers of the students. But the good response, an example of good response is given, considers work from day before, estimated number of children in each class, number of classes in school, age, variations in number of buttons worn, and adults' buttons. Gives reasonable justifications for numbers used. Uses appropriate arithmetic processes. Shows steps used to solve problem. An average response has the following qualities: considers work from day before, estimated number of children in each class, number of classes in school, but misses age variation and or adults buttons. gives reasonable justifications for numbers use, uses appropriate arithmetic processes, shows some but not all steps used to solve problem, and a response considered as poor response refers to previous day's work. Some other values chosen reasonably but some chosen inappropriately, or arithmetic processes used are incorrect. Explanation of steps is incomplete or unclear. These are other examples of performance tasks that may be asked from students. Number one, as a group of third graders who are learning about fractions to show with manipulatives how they would divide different items such as 5 candy bars, 10 pencils, or 11 comic books among 4 students. Another example, have students explain how they would teach a younger sibling to understand the meaning of tens and ones in place value. 3. Give a group of high school students the task of finding the function that best fits certain data by using computer software and a printout of their results. 4. Ask students how many bicycles are there within 2 miles of the school. Have them make a plan for investigating the question and prepare an oral report with overheads or other displays for the class. And the fifth example, as a group of 7th graders, if you measured an object with 5 different rulers and got 5 different answers, how would you decide which answer was correct? This is another example of performance task. Teachers in South Brunswick have been working on a plan to use at least one common performance assessment task across all sections of each grade level in the district. Some of the tasks they've settled on for the first year of the program are: 1. Kindergarten students sort a group of 15 stickers into smaller groups and make up a rule that explains the way they have sorted them. Another task, second graders use toothpicks to make different geometric shapes that each have a perimeter of 8 toothpicks, and then discuss some of the properties of the shapes they have made. And a third example of performance task, fifth graders plan a class party, paying attention to the creation of a budget, the number of people attending the party, and real-world costs of entertainment, food, and drinks. And then write a letter to their teacher explaining the choices they made. Designing appropriate performance tasks is not a simple procedure. Many guidelines must be considered, and the tasks must be tested with real students before they can be used on a wide scale. And so I will show you an example of a set of useful criteria for constructing a performance task. These are the qualities in the first column. You will see the qualities of good performance task. Number 1, a good performance task is essential rather than tangential. And A task is essential if it is aligned with the curriculum. If the task fits into the core of the curriculum and the task represents a big idea. Number two, a good task is authentic rather than contrived, meaning the task uses processes appropriate to the discipline and students value the outcome of the task. Number three, a good task is rich rather than superficial. The task leads to other problems. The task raises other questions, and the task presents many possibilities. And the fourth attribute of a good performance task, the good task is engaging rather than uninteresting, meaning that the task is thought provoking. That means the task would make the students curious enough to engage in the task. And the task fosters persistence. That the task will be able to sustain the effort, will should be able to make the students to persist in completing the task. A good task is active rather than passive, meaning the student is the worker and decision maker. Students interact with other students and they construct meaning and deepen their understanding. A good task is feasible rather than infeasible, meaning the task can be done within the allotted time and it is developmentally appropriate for students. The task is appropriate for the age and grade level of the students. And the task is can be completed within the given time frame or time limit. Task is equitable rather than inequitable, meaning the task develops thinking in a variety of styles. That means the task is fair for all students. It would allow every student to make use of what they know and what they understand, and the task gives every students the opportunity for learning. And lastly, a good task is open rather than closed, meaning that the task contributes to positive attitudes. The task has more than one right answer. It has multiple avenues of approach, making it accessible to all students. That means a performance task considered the individual differences and the different ways that students learn, which resulted to them using different approaches and different ways for solving the same problem. Assessment, alternative assessment method is the use of portfolios. A portfolio is a showcase of student work. It is a place where students can demonstrate their mathematical power in specific and general ways. Student thinking, growth over time, mathematical connections, students' views of themselves as mathematicians, and the problem solving process are each emphasized in creating, maintaining, revising, and assessing student portfolios. In addition, teachers should be working with the students to regularly review their portfolios in order to establish short-term and long-term goals. What should be contained in a portfolio? What's in a portfolio? Many of the following kinds of items may be included in portfolios, but of course, one student would be asked to present all of this, and the teacher may add to this list, and the teacher may discard some of the items from this list. But these are some of the contents of a portfolio: table of contents, introductory and self-assessment letters, long-term projects, daily notes, journal entries, excerpts from dialogue, notebooks, test problems, physical models of mathematical concepts, mathematical models of real-world phenomena, interviews between student and peer, interviews between student and teacher, artwork done by the student, a mathematical autobiography, audio and video tapes of work in progress and or finished products, scale drawings, photographs, homework, peer critics and evaluations, commentary from parents about portfolio contents, self-generated problems and solutions, papers showing students corrections of errors and misconceptions, teacher observations of student group projects, and excerpts from team notebooks. Sample of portfolio assignment given to students in middle school. In this unit, you will be building a math portfolio that demonstrates your understanding of the content. Your portfolio will include several different kinds of work. These are the contents of the portfolio. One cover includes an illustration of one or more of the concepts studied in this unit. Table of contents, a list what is in the portfolio. 2. Self-evaluation, what did you learn? What do you understand well? What do you still need to work on? 3. Key ideas, select 3 to 5 key concepts from this unit. Write about what they are and why they are important, and include 2 examples for each. 4. Work that needs improvement. Explain what you did not understand originally and revise the work. 5. Best work. Explain what you learned and why you are proud of it. 6. Favorite activity or assignment. Explain what you learned and why it is your favorite. And 7. Creative piece. Create a story, poem, or picture that illustrates one or more concepts from the unit. So these are the requirements of the teacher for inclusion in the portfolio assignments of students in the middle school who have just completed a unit in mathematics. Evaluation of portfolios may be accomplished in much the same way as performance tasks or open-ended tasks. Vermont uses a portfolio rating system for grades 4 and 8, in which 7 pieces of work are rated on a 4-point scale for understanding of the task, quality of approaches or procedures, decisions along the way, outcomes of activities, use of mathematical language, use of mathematical representations, for example, graphs, tables, diagrams, manipulatives, and others, and clarity of presentation. Those are the criteria that Vermont uses for grading a portfolio. Portfolios are also used to provide a picture of the instructional opportunities, the content area of programs, and anecdotal indicators of disposition towards mathematics. Many mathematics teachers do not use an elaborate rubric, but they prefer to use a more holistic approach. And this is an example of a holistic approach in for grading a portfolio. And the highest, the best level, top level, level 4, has the following attributes: exciting, includes a variety of work. The portfolio includes a variety of work with evidence of use of many different resources. Papers show understanding of content, organization, and analysis of information. There is clarity of communication, enthusiasm for mathematics. And the portfolio includes self-assessment. This best or top level will get the highest score, and the teacher has to decide for the scores to be given for each of these level. And level 3 has the following traits. The portfolio at level 3 has the following traits: variety of work, there is variety of work, fairly good explanations, it's some use of resources, the work shows good understanding of basic mathematics processes, but there are missing indications of enthusiasm, self-assessment, extensive investigations, and or student analysis of information. If the teacher will use a 4-point scoring for the portfolio, level 3 will get a score of 3 points. Portfolio at level 2 has the following attributes: there is little evidence of original thinking, minimal student explanations, over concentration on low level tasks such as computation. And at the lowest level, the portfolio almost shows no creative work. Portfolio is mostly a compilation of useless sheets or textbook problems. There is no evidence of student thinking, no evidence of discussion of mathematical ideas, and there were no explanations. Are some of the suggestions for assigning a portfolio assignment to students. Number 1, to demonstrate students' growth over time, pose similar questions periodically throughout the year. These questions should explore the same content in different situations. Include observation checklists, interview notes, and parent communications regularly. 3. Keep 2 portfolios for each student, a work portfolio and an assessment portfolio. Have younger students keep work portfolios in a plastic crate or box to pick up as they enter the room. Older students may use a notebook. Include journals in portfolios and put copies of group work in the folders of each group member. Every 2 to 6 weeks, have students review their work portfolios. They should make a list of all the work they have completed, make revisions if they wish, review their journals, and circle or label pieces that they feel reflect growth or understanding. Ask them to select work to put in their assessment portfolio, writing a paragraph about each item selected. Another assessment strategy used by mathematics teacher is the mathematics journal. A mathematics journal is a small booklet or notebook in which students write on a regular basis. A journal entry can be a regular daily part of the mathematics class or something just done occasionally. The mathematics journal can be very structured, with the students responding to a writing prompt from the teacher, or very free, with the students choosing their own mathematics topic and question to write about. The mathematics journal is not graded since teachers want students to write freely in it. The consistent aspect of the mathematics journal is that it provides a means of communication between the student and the teacher. It is a vehicle by which the student can express understanding, attitudes, delight, creativity, and a lot of other responses. Students frequently have a hard time creating journal entries when they first begin to write, especially if they are already well advanced in school. Now, here are some examples of prompts, journal prompts from a collection being created in South Brunswick. And these journal prompts can help students feel more comfortable and more focused in constructing an entry. Here are examples of journal prompts, and the students will answer these questions in their mathematics journal. Number one, how would you teach someone to add two-digit numbers? 2. What is one area of mathematics you feel confident in? Why? 3. Judy was absent today. What will you say to her if she calls you tonight and asks what we did in class? 4. Write a story problem using this number sentence: 65 minus 32 equals 33. Next, write everything you know about the fraction 1/2. Next, make up a rhyme or a funny sentence to help you remember the algebraic order of operations. Next, the most important thing I learned in math this week was, and the student will continue the sentence in his or her journal. Sample, make up a number pattern and tell about it. And last, describe what is going on in your mind mathematically right now by completing one of these statements. Think, I feel, I know, I wonder, I guess. The student will simply choose one of these and will write a complete sentence beginning with these first two letters. And the student will write everything what's on his or her mind in his or her mathematics journal. Teachers who have students write in their mathematics journal are, of course, obligated to read and respond frequently to the entries. But they will find many of the students' responses refreshing and original, and the process will be one of the most pleasant of their tasks. To reduce the amount of time spent reading journals, some teachers have students box or underline portions which they would like the teacher to read. Opinions vary on whether or not to give comments, especially ones that suggest corrections or a need for improvement. Some teachers like to put comments on post-it notes so as to leave students' work unmarked. Mathematics journals frequently are good sources of information about students' attitudes and misconceptions as well as emerging classroom problems. Teachers can often find out more about the students' thinking and degree of understanding from the journals than from most other methods of assessment. Observations, interviews, and conferences are another alternative assessment methods. And all of these provide both the teachers and students opportunities to assess progress. At the heart of these types of assessment is the student and teacher working in collaboration in order to ascertain the progress the student has made. A student can analyze her or his own mathematical work by focusing on the quality of the product, the need for revision, changes, or additions to be made, and different problem-solving strategies to employ. Performing an effective critical analysis of one's work is a process that students can adopt for use later in life in their careers. These are some of the suggestions for using observation, interviews, and conferences. Number one, write observations on index cards or on a sheet of address labels that can be transferred to student portfolios later. Some teachers print up labels with names corresponding to the seating chart so that it is easy to locate students. 2. Give the same problem to the whole class, but choose one or two groups to observe closely. 3. Use a checklist of observation details for each group of students. Rate each group or simply check if you see the behavior on such items as whether all members are participating, whether they are estimating before computing answers, whether they are using more than one process, whether they are recording their work, whether they are reporting their work, or whether they evaluate themselves. The last set of alternative assessment methods for our lesson today includes seminars, labs, and extended projects. Assessment may also include student presentation or seminars, labs, and extended projects, particularly in the higher grade levels. These methods assure the connection between instruction and assessment, as well as provide opportunities for relating mathematics to other subject areas or learning areas. These methods are especially appropriate for assessing students' ability to identify and define a problem and what they already know, to make a plan, to create and modify problem-solving strategies, to collect, organize, and analyze needed information, to discuss, review, revise, and explain results, to persist in work on a problem, and to produce a quality product or report. Possible topics for these types of assessment might include maps, gears and ratios, sound waves and music, traffic patterns, collecting and analyzing litter, studying local water use, census studies, lunch preferences, sports statistics, plant growth, measurement of parts of the body, or nutrition. These are examples of projects that may be assigned to high school students. All projects involve a final presentation to the class, either in person or in videotape. And these projects are plan a day trip to an amusement park, redecorate this classroom, origami or tangrams, logic puzzles, conduct and evaluate a survey, menu planning, chores, and consumer reports. And that completes our lesson for today on alternative assessment methods. If you have question about the lesson today, please ask your question in the comments below. Thank you for joining me in my class today in assessment and evaluation in mathematics.